Today's video is on the mean absolute deviation of a set of data. We need to think about what that vocabulary means because some of us might not be familiar with some of those words. So we learned about absolute and we talked about absolute value. So we know with absolute value, it's comparing distance. So we should be able to glean from that mean absolute deviation has to do with distance. And that makes sense because this is another measure of variation. We've already learned about range and interquartile range, which are single numbers that represent how far spread out a data is. And so the other key word here is the word deviation. And so what that word means, if you were to break that out, when you deviate from something, you stray or depart from the normal course. So deviation is a measurement on how far something is from the norm. Okay, so we're going to be talking about mean absolute deviation. I'm going to give you an example to help you to understand what that means. So here, this was an activity we meant to do in class together, but I'm just going to kind of have it completed for you ahead of time so we can use it to help understand the basic concept. So we basically looked at these students. There's looks like 14 students and their exam scores, and we found their mean. So we added up all of their exam scores and divided by 14, and we found that mean was 88. Then we put all of their scores on a dot plot, and I've identified the 88, which is the mean, because nobody in the group actually got an 88. But the mean falls kind of right in the middle of where the data is, which makes sense because the mean should be representative of everybody's scores. But we want to make sure we're recognizing that the scores varied quite a bit. And so what we're going to do is we're going to notice, look how far apart they are, and they don't all really cluster right around the mean. That tells me that this data is very spread out. And that's great if I can have a line plot to kind of show that data. But our goal for this unit is to be able to find a single number that can represent how far apart the data is. Now, one of those goals we've done before, which was to find the range and the interquartile range. So I can find the range of this data by comparing the highest number and the lowest number, and clearly the range here would be 20. All right, because we would subtract the upper extreme and the lower extreme to get a range of 20. That tells me the data is pretty spread apart. But then what we also can do is look at the interquartile range. So you can see I split my data in half, right down the middle, and you can see that our median was 89. The middle of the lower half of the data, quartile 1, or the lower quartile, was 84. And the middle of the upper half of the data, quartile 3, or the upper quartile, was 94. So if I wanted to find the interquartile range, which we know abbreviate IQR, the IQR we could calculate by subtracting the third quartile minus the first quartile and find that the interquartile range is also 10. Again, those large numbers indicate this data is pretty spread out. And that's important statistically to recognize when data is not very clustered, when it's really spread out. And again, that was evident on our dot plot. But when data is really spread out, that tells me that there isn't a lot of consistency in the data. And that's worth noting. As a teacher, we would like to see most of our scores fall right around the same spot. But when you've got data that's really spread out, that can be concerning. So now another measure of variation is called the mean absolute deviation. So the mean absolute deviation is an average of how much data values differ from the mean. So, we know that the mean of this group of data was 88, but how far is that 96 from the 88? It's pretty far. How far is that 76 from the 88? It's pretty far. And so what we're going to note is this helps us to indicate how far spread out the data is. So here are the steps for finding mean absolute deviation. And I will tell you, this is a little overwhelming. There are a lot of steps involved. But as you're going to see in today's video and in tomorrow's video, the process, once you've kind of got it down, it's just a matter of following these steps. So the step 1 is to find the mean of the data. Step 2 is to find the distance between each data value and the mean. Then step 3 is to find the sum of those distances, and then step 4 is to divide that sum. Now let's let's take this literally one step at a time and see if we can do this process so it doesn't seem, because these words are a little overwhelming. So here's a real life scenario. Let's say you went down to the boardwalk and you found a store that was selling kites. And to fly a kite on the beach would be something we'd all probably enjoy doing right now, in this situation. But let's look, the prices vary pretty significantly. But pretty significantly isn't a math term. We want to be able to have a numerical value to indicate how much they're spread out. And so the first thing we're going to do, if you'll remember, step one is to find the mean of the data. So I've done that for you. I added up all of the prices of the kites. It was a total of $160 for all 10 kites. I divided that by 10 to get a mean price of $16 per kite. So that's step one. Now, our second step is to find out the distance between each of those data values and the mean. So how far is $7 from $16? How far is $20 from $16? And again, I've done that work for you. I've put those numbers in parentheses directly below. And I think it's interesting, to look at this, is that if you compare, $12 is 4 away from that mean, but so is 20. And so we think of the word absolute. We talked about absolute value, how it's a distance. It doesn't matter whether that distance is higher or lower, just how far away it is. So that $9 kite was $7 away from the mean. That $15 kite was only $1 away from that mean. And look, that $35 kite was really far from that mean. So these are absolute deviations. But remember, our goal is to find the mean absolute deviation. So what we're going to do now is we're going to add up all of our deviations, our absolute deviations, and divide that by 10. So if I add up all of those numbers in parentheses, I get 72. If I divide that by how many terms there are, which was 10, I get a mean absolute deviation of 7.2. Again, this gives me an individual, specific one number that tells me how far the data is spread from the mean. So again, those 4 steps seemed a little overwhelming when given all at once, but if you think about it, finding the mean, we already know how to do. Finding the distance from the mean is just simple subtraction. Then finding that sum and dividing it by how many terms is the last steps you'd follow. So we'll do another example, and this one we'll do on the prices of microphones. So here we've got some data. I like it when the data is in a table like this, because what I'll do is when I calculate it, I'll actually make a second table to track those deviations. And so you'll see that in a moment. And that wasn't as neat as I'd like it to be. So the first thing I'm going to do is I'm going to get the total sum of all 10 microphone prices, and I'll use that so I can find my mean. So 25 plus 28 plus 20 plus 22 plus 32 plus 28 plus 35 plus 34 plus 30 plus 36 gives me a total of 290. Now with 10 microphones, if I divide that by 10, I could do that in my head, but I'll just prove it to you, that answer was 29. So that means the mean is 29. That's my mean. Now, to find my mean absolute deviation, I need to find out how much each of those numbers deviated from that mean. So 25 is 4 away from that mean. 28 is 1 from that mean. 28 again is 1 from that mean. 35 is 6 away. 34 is 5 away. 20 is 9 away. So you're seeing I'm basically just finding out how far apart the actual data is from the mean that I calculated. So now that I've done that, remember, mean absolute deviation. These are my absolute deviations. This deviated by 3. This deviated by 7. You can see how I put them in corresponding places in my chart. Now what I'm going to go ahead and do is find the mean of that information. So 4 plus 1 plus 1 plus 6 plus 9 plus 5 plus, I could say that I messed up there. Let me start typing that again. 1 plus 6. And that gives me a total of 44. I'm going to add that one more time because I definitely felt like I rushed through that. Yep, it was 44. And so that tells me my mean absolute deviation will be 4.4. Okay, and we do abbreviate that MAD. So there you go, 4.4. And so to find out that that mean absolute deviation is much closer, the prices of these microphones with a mean absolute deviation of 4.4 tells me those prices are a lot closer together than the prices of the kites. So we'll do one last example. We're finding and interpreting the mean absolute deviation of the data. So the first thing we're going to do is we're going to find the mean. Remember, the steps are, step 1, find the mean of the data. So 5 plus 8 plus 8 plus 10 plus 13 plus 14 plus 16 plus 22 gives me a total of 96, just like I did with all my means. I'm going to write that total, and then I'm going to count how many terms there are. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to divide that by 8. 96 divided by 8. That's a basic fact. So that tells me my mean is 12. Now what I want to do is indicate how far apart these numbers are from that mean of 12. So I'm going to write those in parentheses directly below. So you can see that I've written all my absolute deviations. So I've now found the distance between each data item and the mean. So now I'm going to add up those distances. So let's get that total real quick. And I got a total of 34. And then we're going to divide that sum by the total number of data values. And if you'll remember, that was 8. So we're going to do 34 divided by 8. And we got 4.25 as our mean absolute deviation. And again, that tells me that that is pretty close together. The smaller your range, interquartile range, or mean absolute deviation indicates the closer the data varies. So we spent a lot of time last week, the week before, learning about measures of center, and then last week we began learning about measures of variation. So understand that measures of variation, it's a single number that tells you how far the data is spread out. The smaller the number, the more the data is clustered. The larger the number, the further it's spread out. All right, good luck on your form.